So to make this look like y equals mx plus b, I just basically have to solve for y, right? So I'm going to minus x from both sides. Minus 1x, minus 1x. And I'm left with 2y equals negative x minus 6. Next, I'm going to divide everything by 2. Remember, when you multiply or divide, you have to do it to every term in the equation. 2 divided by 2 is 1. 1 times y is y. And then we could just rewrite this as negative 1/2 x. What's 1/2 of 6? 3. So this is our... Oh, I made a boo-boo. That should be greater than or equal to, right? That's what we started with up here. Okay, so how do I graph it? Well, we have to remember that it's written, the reason we went through all that stuff is to figure out what the slope is and figure out what the y-intercept is. So to graph this bad boy, we start with the y-intercept. Remember that b is the y-intercept. Well, that's this right here, which is negative 3. In other words, my graph will cross the y-axis at negative 3. Now, my slope is the next little ditty that I need, which is the number in front of the x. And it's a negative 1/2. That means I'm going to go down 1 and then over 1, 2. Repeat that process. Go down 1 over 2, go down 1 over 2, go down 1 over 2, down 1 over 2. I could repeat it in the opposite direction. Basically, I'm going to form a line. That's why they're called linear. Okay. Now, the next question I have is, do I do a solid or dotted line? What do you guys think? Solid. Why do you say that?
Because it's not the line.
I got an equal sign, so that means it's going to be a solid line. Now, mathematically or conceptually, what that means is that I'm going to define an area on this graph where any x or y, any x-y combination, in other words, if I pick a point in the shaded region, that x comma y will satisfy or make this inequality true. The solid line says, and we can include the points on the line. A dotted line says everything that's shaded, but we're not including things on the line. It's like the open circle, closed circle, except it's in a two-dimensional Cartesian plane, named after Rene Descartes. That's why we call it Cartesian plane. He kind of invented this stuff. So now the next thing is, what is this inequality symbol? Greater than or less than? So remember, think of the number line. If I'm going to the left, this is how I always remember. If it points to the left, then it's less than. Left, less. That's all I need to know. But this one's pointing to the right, so there's greater than. And it's got the little equal symbol, so you would say greater than or equal to. So if I read this out loud, I'm saying y is greater than or equal to the rest of the stuff. So think in terms of the y direction. What is greater than this line? Above or below in the y direction? Some of you guys are pointing up. So yeah, it's above the line when you have a greater than. And so you could shade this in. I just draw little lines because I was never good at coloring, as you could tell. Sometimes when you do an inequality, or not an inequality, like a system of inequalities, it's better just to draw the little lines anyways. All right. Cool. How do I double check this answer? Yeah, we just plug it into Desmos. So I'm going to go into Desmos, and I'm actually going to type it exactly how I see it. X plus 2y, the original inequality. Now here's the trick. For it to be greater than or equal to, you gotta do the greater than symbol first. And then to tack on the equal to, I'm going to hit the equal button, the key on my keyboard that has the equal sign. As soon as I hit that, it automatically changes it to greater than or equal to. And then negative 6. There it is. We'll take a screenshot of that. Does that look like what I just graphed? Yeah. I suppose what we could do, which just for fun, is maybe identify the x and y intercepts. Right? And then check it on this thing. So if I slide my graph way up here, I've got an x-intercept at negative 6 comma 0. Is that what I have on my graph? Yeah. Right here, this is negative 6 comma 0. And then right here, this point is 0 comma negative 3. And that's what I got on my graph here. So I did it right. Then a solid line, I have a solid line. Just different colors, really. Oh, I didn't even plan this. That's Christmas colors. Merry Christmas.